Okay, so we're going to try to do a video, or I'm going to try and do a video using my document camera this time instead of using Smart Notebook. So hopefully this goes okay. Let me know if you can't see or it's unclear. So we're going to start getting into solving equations in this unit. Basic equations is 2.3, and then we'll start getting into more complex equations later in the unit. So today I want to first give the definition of what really a solution is to an equation. When we're talking about solving for something, a lot of us use this word solve just for anything, but in reality, solving in algebra, you're trying to find a very specific value that makes the problem work. So the way we can define that is a solution is a value of x, typically. Sometimes it's something else, or we can write or a variable. That's the bell. Ignore that. That makes an equation true. Okay. So that's the basic definition of a solution. We're looking for a missing value that makes the equation true, that whatever problem we're solving is what we're looking for. And there are a couple ways we can find this value of x. And that's kind of what all algebra is really, is how are we figuring out what these missing values are? And we're going to start very basic today. So the first way that we can solve problems is kind of by using logic. So if I look at these first couple problems here, let me zoom in. And I want to solve by logic, x plus 5 equals 7. So I'm looking at x plus 5 equals 7, and logically I'm thinking, okay, what is that missing number that x has to be for when I add it to 5, I get 7. This is a very simple one, right? That means that x has to be 2. Okay, so what added to 5 gives you 7? That's the question you're asking. And what added to 5 gives you 7? The answer is 2. 2 plus 5 equals 7. So my answer to this equation is 2. I didn't do any special solving tricks. I just thought to myself, well, what does it have to be to give me 7? Similarly, for 10 minus x equals 1, I'm asking myself here, what subtracted from 10 gives you 1? That's the question, right? What subtracted from 10 gives you 1. So if I'm thinking about that, okay, what number do I take away from 10 to give me an answer of 1? The answer has to be 9. 10 minus 9 equals 1. So this is solving by logic. I'm just taking the problem, I'm thinking it through, what has to be that missing number to make my equation true. Okay, and for equations like these that are very simple, we can use this method, right? Because these are simple addition and subtraction problems we've been seeing kind of all through math classes in school, okay? But what happens when we get to equations that aren't as easy to logically think through? Okay, I don't know why this is tilted a little bit there, that's better. What about equations that aren't as easy to logically think through, right? So a problem like this, 2x plus 4 equals 12, there's a lot of stuff happening to x besides just adding 5 to it or subtracting 10 from it, right? We're multiplying the x by 2, and then we're adding whatever that is, 4, and we're getting an answer of 12. That's a little bit harder to logically think through. So one way we can think about this process is this idea of undoing. And this idea of undoing is going to follow us through all the way through the end of the year, truly, and into geometry and algebra too. So this is a really important concept. So one way I think of this type of problem is I want to list what's happening to x here. So I'm going to go over here, and the first thing that's happening to x is being multiplied by 2. I always start at the x, what's happening to x being multiplied by 2. So that's my first thing that's happening. So it's being multiplied by 2. Okay. The next step, I'm drawing an arrow because that's the first thing that happens. What's the next thing that happens? After I multiply by 2, then in this equation we're adding 4. So that's the next thing that's happening to this. Okay. And that's the end of my equation. So I multiplied by 2, added by 4, and I got to the end result of 12. If I want to undo this problem, if I want to go backwards then, and I want to start solving, okay, and this is the undoing. I'm starting at the bottom. I'm going to undo it. What would the undoing of adding 4 be? The opposite of adding 4 would be subtracting 4. And then after I would subtract 4, the opposite of multiplying by 2 would be to divide by 2. Okay, this right here, this process of starting, dividing by 2, and subtracting by 4, that's my undoing. Okay, and we don't have to do this writing it out for every problem, but I'm trying to give you this idea of how we're starting with the equation, and then to figure out and work backwards, we're undoing it. Okay, so you're going to notice when I start to solve this the way you've done it in middle school, you're going to see that I'm basically going to be following these instructions I've given myself that I've highlighted. I'm going to start here by drawing a line through the middle to separate my left side and my right side. I want us all doing that to keep our work neat and organized. So draw your line separating the left and the right. And then I'm going to follow these directions. My first one is subtracting 4. So I'm going to go to the left and I'm going to subtract the 4. Remember, in an equation, whatever you do to one side, you have to do the other side to keep it balanced. Okay? You can't just subtract 4 to one side and not the other side. It won't work. So these cancel out to 0, and I'm left with 2x on the right, on the left, and on the right, 12 minus 4 is going to give me an 8. That was my step 1 of subtracting 4. What's my next step in my undoing? It says divide by 2. So I'm going to divide both sides by 2, and that makes sense because to get the 2 and the x apart, they're connected by multiplication. I need to undo them by division. That cancels out to 1, so it goes away, and I'm just left with x equals whatever 8 divided by 2 is, which is 4. Okay. So this is the process that we're going to start to use to solve these more complex equations. Like I said, I don't need us to be writing these out every time, but I do want you to see that this idea of going backwards is effective and will get you the right answer. And if you're not sure if something is the right answer, there's always a way to check. So if I go over here and I want to check my work, let me move my cursor over here. If I want to check my work to see if 4 is correct, I'm going to take my equation, 2x plus 4 equals 12, but instead of the x, I'm going to put a set of parentheses, I'm going to plug 4 in, and I'm going to see if this works. 2 times 4 gives me 8, 8 plus 4 gives me 12, and is my equation true? Yes, because both sides are the same. So that's the nice thing about equations is that you can always take an answer that you get, plug it back into your original problem, and see if it's correct. It's one nice thing about these, okay? All right, let's do a few more examples here, okay? So the first examples are how do we solve equations with variables on just one side? And I'll do 2 more of these examples here. So like the first one, you draw your line down the middle, and then you're going to subtract the 3 on both sides first. You always want to try and isolate the variable here, and so you want to do that by getting rid of the whole numbers first. So the 3's go away. Negative 17 minus 3 is negative 20. You're going to want to use your calculators because you're going to make sign errors. Sign errors are the biggest problem in this unit, is if you're just not careful making sign errors. Now, I can do a lot of this math in my head. I've been doing it for a really long time. But when it comes to students that just aren't as experienced with negatives, this is where we tend to make mistakes. So I just encourage you to use that calculator, okay? The 2x comes down, and then I'm going to divide both sides by 2. And I get x equals negative 10. The second problem is similar. We're still going to draw our line down the middle of the equal sign. But now I'm going to add the 5 to both sides, like I did with subtracting the 3. These 5's cancel out, and I'm left with negative 4x equals 67 plus 5 is 72. I believe. And then we need to divide each side by -4. And I don't know that off the top of my head, so I'm going to use my calculator. 72 divided by -4 gives me 18. So x is equal to 18. Make sure that when you are writing your answers, you're boxing them or circling them so I can see them really easily. And make sure your work stays neat and tidy. If you do make a mistake and need help, if your work is neat and tidy, you can come show me, and I can see easily where you might have made a mistake. It's okay to have the variable on the right side. So in these two examples, we had the variable on the left side. But in some problems, you're going to have the variable where it's on the right side, like in this problem. Okay, so we're going to solve it the same way. Draw our line down the middle. Let me scoot this up a bit. Okay, so we're going to go ahead and, like the other ones, get that whole number to the other side. The 15s cancel out. -35 plus 15 is -20. Bring the 5k down. Then divide both sides by 5. These cancel out, and I'm left with k on the right now. And -20 divided by 5 is 4. But if you get a variable with a right as your answer, I really want you to rewrite your solution with the variable on the left. So when you write your final answer, you're going to write it like this and circle it, put a box around it. K equals 4. Okay. The last type of basic equation I want to go over in this learning target is if we have a variable on both sides. Okay, so the same way we're going to start, draw our line down the middle. And if I have a variable on both sides, I want my variable on the left. Just like I just talked about a second ago, where I want you to rewrite that variable on the left side. When you're solving your equations, you want to try and get your variable on the left side. So I notice that I've got this 5n on the right. So my first step is going to be to undo that and add the 5n over to the left. Notice when I write it on both sides, I line it up with its like term. So this is a 5n under 5n, and then I line it up with the 3n on the other side. Then I draw my line. These cancel out. -3n plus 5n gives me a 2n. Bring down my -15. Bring down the 1. Now I want to try and get n by itself. So I'm going to add 15 over. The 15s cancel out, and I get 2n equals 1 plus 15 is 16. Divide both sides by 2. The 2's cancel out, and 16 divided by 2 is 8. So I get 8 for my answer for that problem. We'll do another example here on the right. Draw your line. Okay, again, I want my variables to be on the left side, so I want to get that 4x on the left, which means I have to get rid of it on the right. So I'm going to subtract 4x. Because 4 is positive, I have to subtract it away. I'm going to subtract it on the left side as well. These cancel then to 0. And on the left, -4 and -4 give me a -8x. Be careful with your signs. Bring down the -10 and bring down the 6. Now I need to add the 10 over. So I'm going to add 10 to both sides. They cancel out, and I get -8x equals 16. And then the last step, divide that -8 in front of the x, and I get x equals -2 as my answer. Okay. And then the last example that I'd like to talk about is one where we have to kind of combine like terms first. So I'm going to draw my line like normal here, but I'm going to notice that before I start adding or subtracting anything, I'm going to look for like terms. And we've talked about this in Learning Target 2.1. On the right side, I have 6x and 4x. Those two things are like terms, so I'm going to combine that into 10x and bring down the 7. And over here, I've got a 3, a 4, and a -16 that I can combine. I'm going to use my calculator for that to help me here. So in my calculator, I'm going to do -16 plus 4 plus 3, hit enter, and I get negative 9. So now I'm going to bring down the 2x minus 9. And now I've combined like terms, and now I've come up with a much simpler equation. Okay. Now you're going to treat this just like we treated the other two. Start off by getting rid of that variable on the right. So we're going to subtract 10x on both sides. The 10's cancel. 2 minus 10 on the left is negative 8x. Bring down the negative 9. Bring down the 7. Then I'm going to add 9 to both sides. The 9's cancel. I get negative 8x equals 16. Just like the other one, actually. Divide both sides by negative 8. And I get x equals negative 2 for my final answer. Okay. So your biggest takeaways from this learning target are really, this idea of undoing and this idea of keeping your work really nice and neat. Okay, drawing that line, keeping both sides very clear and distinctive. Okay. Good luck. Ask for help if you need it. You've only got 2 pages of practice, so it shouldn't be too terrible.